is good. But this is kind of putting it all together of what can I use complex numbers for to solve an equation, basically. And so this is the only reason I put it in your notes is this one page, but I'm still making you write the formula yourself. But it says, like, if you have a complex number, a plus bi, that's what we've been working with, it is the nth root of the complex number z if you raise it to a power. And just think about, like, if I had, like, x cubed equals 7, right? We would say the cube root of 7 is a cube root of this equation. So we're just saying, like, if you have it to a power, it could be any number, then we could take the nth root of it. With me on that so far? So that n determines the n in the formula here. So it says, I don't know what, like, n's not supposed to be up here, but nth root of a complex number. So if you have a positive integer n, so that's the power, like the second power, the third power, maybe we even do one to the fifth power. You have to put your formula in the trig form again, so that's the tough part, just like number 35 that we just did. If it's in a plus bi form, you have to be able to put it in this form. And it will have n distinct roots. That's fundamental theorem of algebra right there. If you have something to the third power, there are really 3 roots. Sometimes they're imaginary, sometimes they're not imaginary. So if you're trying to find the 5th root of an equation, there's actually 5 answers, and that's what we're going to do today. So I'm going to show you this, and you can gasp in awfulness, and then write it down, and then we'll talk about what it all means, okay? It's really not as terrible as it seems, but it looks terrible. I will admit to that. So, the n out there is the nth root, right? So if we were doing the cube root, it would be 3. It would always say 3 in this problem. Theta is going to be the theta that you have already in the problem when you put it in trig form. And then k starts at 0, and you go up until you find all the roots, right? So if you had to do the cube root, you would do this equation for k equals 0, and you'd get an answer. And then you do it again for k equals 1, and you'd get an answer. And you do it again for k equals 2. So that's where this n minus 1 comes from, because you go up to 1 less than the number of roots you have, because it starts with k equals 0. So if you were finding the 5th root, you'd have to do 0, 1, 2, 3, 4. So if you just remember to start with 0 and stop when you have enough roots, you don't have to keep going there. And the nice thing is that this is the same on both sides, so you'll see in a minute, like I always start it. That's where maybe the CAS form is better. And then we're just going to kind of work it out. And maybe we'll even kind of see that if you're doing like the 5th root, you can see that there's a pattern, and maybe you have to do all the work every time. So you do theta plus 2 pi times whatever k value you're on, divided by the roots that you're taking. All right, so this is our formula. Make sure you get that part down, and we're just going to practice it. It's much easier when the directions say leave it in trig form, because then you can just leave it. Otherwise, in standard form, then you have to work it out as well. All right, so let's just jump in and practice it with real numbers here. We'll start nice. We'll start with square roots, because there's only 2 of those. So it says find the indicated roots of the complex number, give standard and trig form. So also we're starting nice because this is already in trig form, so you don't have to do that extra step of putting it in trig form. So this is your R, right? If I'm finding the square roots, that means n equals 2. And I'm just going to do that formula, and I'm going to like write it all out just so you can kind of see where the numbers fit in with the formula. So this is going to be the square root of 16 times cosine of theta. So now let's be really careful for a minute. If we go back here, this says theta plus 2 pi k. Now this is when theta is in radians. So since my problem's in degrees, you got two options. One option is that we could change it to radians, or the other option is, what are we going to replace 2 pi with if we're in degrees? 360. So you have to kind of decide if you want to just always do 2 pi k, change it to radians, or for me, I'm just going to say that 60 plus 360 times 0, that's my k value. There we start with that. So the 360 is if in your degrees. So if you want to go back to that formula and you want to write 360 up here in degrees, you can do that. Hopefully we're to the point that we feel pretty good about knowing that 2 pi and 360 are the same thing. And then divided by n, which is 2. We're going to question where I got those numbers from. Maddie. You always start with 0, right? K equals 0, and it goes on. You do it every time until you get to n minus 1. So on this one, if it helps, you can figure out first, how many times am I going to have to go with k? Well, if n equals 2, n minus 1 would equal 1, right? That just means you have to do it twice. So this is for when k equals 0, and we're going to have to do it again for k equals 1. And that's the n minus 1. So you always start with 0, and you go up to 1 less than your n. But you would start with 0, so you would really stop at n equals 2. So I don't really think about the n minus 1. I just always think start with 0 and go until you get the number of roots you're supposed to have. Like for me, I think about square roots. I only need to do it twice. Does that make sense? So 0 and 1. Cube roots, I need to do it 3 times, which would be 0, 1, and 2. And we're going to do some more, so hopefully that'll kind of fill that in. And then I'm going to write it on this one, but you're going to see in a minute, I get very tired of writing it because this is going to work out to be the same thing. And so I'll show you how I write it in a minute. So that's still going to be 60 plus 360 times 0. Be really careful in your calculations. For some reason, people like to make up their own order of operations. Either type it in your calculator, but order of operations, you're going to multiply, then you're going to add the 60 before you divide the 2 on the bottom, right? And so type in your calculator if you want, but just be really careful that it's the top first. If you don't put that in parentheses, your calculator might give you the wrong answer. So, like, that's just going to be 0, right? K equals 0 is the easiest. That's just 0. So 60 divided by 2 is just 30, right? Square root of 16 is 4. So that's going to be 4 times cosine of 30 degrees plus I sine of 30 degrees. So, just the index, but in square root, we don't usually put a 2 out there, right? But if it was cube root, but if I remember in square root, there's a tiny little 2 out there. Other questions on where I got that? This one says give both standard and trig form. Well, you're going to get trig form every time because that's the formula. So that's one answer. To get standard form, that's what we've been doing this whole section. That's just where you work it out, and that's where you have to know your unit circle. At 30 degrees, let's see if I can do this right this time. At 30 degrees, that's going to be square root of 3 over 2 1/2. So that's square root of 3 over 2 plus 1/2 I. So if I multiply the 4 in there, that's 2 square root of 3 plus 2I would be my standard form answer. Then I'm going to do it again, but now what's going to change is k is going to be 1 instead of k is going to be 0, and it's going to give me another solution. So I'm going to say 16 times cosine of 60 plus 360 times 1. Right? All that changes in this formula is the k value. Everything else stays the same. And then I just always put plus ... and I figure it out. I figure out what that equals before I actually Like there's no need to write it twice. I don't. So 360 plus 60 is 420. Divided by 2 is 210. So that could be cosine of 210 degrees plus I sine of 210. And again, if it said leave it in trig form, you're done. But this one says to actually work it out, which means again, you got to know where 210 degrees is. Which is down here. And it's just that they're both negative, right? So it's going to be the exact same point on my unit circle except negative. So if you recognize that, you could just say that's going to work out to be the same thing but negative, right? That's going to be negative 2 square root of 3 minus 2i. Yes, dear. For square roots, does it seem to make sense on square roots that it should be like that? It should. On cube roots and fourth roots and fifth roots, you're going to see a difference in there. So, but square roots, it makes sense. We usually get a plus and a minus. That's what should happen. But if it says give the trig form, you got to do the work to get the trig form still. So know what that is. Questions about it? Let's do another one. So cube roots, right away when I see cube roots, I know that n equals what? 3. And I know that that means I'm going to have 3 answers, right? So I'm going to have to do this 3 times. K equals 0, k equals 1, k equals 2. And that's where n minus 1 comes into play, because 3 minus 2. 3 minus 1 is 2. So this is where you have options. One option here is we could distribute the 8 in, and we could do the r theta thing as well. Another option could be here. Do you recognize this as a point on your unit circle? Yes. So it's kind of like this. To me, this is like in between trig form and standard form because they didn't distribute the 8 in already. Which means, does it make sense that this is my r value? You want to distribute it in and work it out, I promise we'll still do that works out the same way. Where is this? Where is the point negative 1/2 radical 3 over 2? Negative 1/2, that's over here in quadrant 2, yes? Up here? 2 5/3? Alright, so again, all that unit circle stuff, kind of recognizing the forms. The other option here is if you have no clue where I got that from, you could distribute the 8 in here and make that negative 4 plus 4 radical 3, and you could find r the old way, instead of sine, cosine, tangent. But I hope since that's the unit circle that kind of makes sense that that's where that comes from. So in trig form, I'm going to write this as 8 times cosine of 2 5/3 plus I sine of 2 pi. So that's step 1, and now it's plugging it in. And again, notice I did gradients. I just always do gradients unless they gave it to me in degrees. If you wanted to say 120 degrees there and you want to add the 360k, you could do that. But I'm going to do gradients just because I feel like it's just less. So this would be the cube root of 8, right? Because it's the nth root. So it's the cube root of 8 times cosine of theta plus 2 pi times 0, all divided by n riches. And again, I always just write it for the cosine because it's going to be the same thing for the sine, and I just work, like I write that for my work, and then I work it out myself. Question where I got those numbers. Again, remember, it's really nice when it's 0 because that's just going to be 0, but then you're dividing by 3 here. Cube root of 8, that works out nice too, right? That's just 2. And if I take 2 pi thirds and I divide by 3 again, that's just multiplied by 1/3. So it's like you just take 3 times 3 in the bottom. And that just becomes 2 pi ninths. Plus I sine of 2 pi. Questions right at that. Is 2 pi ninths my unit circle? Which means, if the directions are the same as number 1, which is give standard form 2, that's where you have to use your calculator. And you're just going to get a decimal answer. You're just going to round to 1 or 2 decimals, whatever it says, or it doesn't say. It's not a trick. So in standard form, I'm just going to take, in radian mode, 2 times the cosine of 2 pi ninths. And I'm going to get about 1.53. And 2 times the sine of 2 pi ninths. I'm going to get about 1.29 I. Standard form, trig form. No, because this has an I and this doesn't. So my 0 kind of already ran into my 1 here. So that's one answer. Now I get to do it 2 more times. Which is why you only have 4 pops in homework. Yes. It's not square root, it's just a cube root. Like, it's just the nth root. So on the last one, it was a square root. So that's why, like, we don't put a little 2 out here for a square root. But it was just a square root. Because this says a cube root, it's just a cube root of 8. So you just, on your calculator, I think there's a cube root button, maybe? There's just an X root button. So you have to hit in the root first. So you have to hit 3 on the cube root. You hit that button, and you have to hit 8. Again, if it doesn't work out nicely, in trig form, I would expect that you would either leave it or you would simplify it if there was a cube root in it, like you could break it up. Right. 2 pi over 3 divided by 3. Because we're adding 2 pi now, right? That's going to change. That's what's going to change every time it's your equal. So you're going to have to add 2 pi first. So let's do that. So now I'm going to have, and if you want to go ahead and write 2, you can. You can write the formula again just to kind of get used to it. The more you write the formula, the easier it's going to be to remember. So this is now 2 pi thirds plus 2 pi times 1, all divided by 3. And you have a calculator. You can take the pi out of it and just do the fractions. You can just do 2 thirds plus 2. Then you can divide by 3. And you should be able to get that in fraction form. If you don't know how to use your calculator with fractions, you need to see me before the test, because you should be able to give me fractions here. I'm just going to do it here. 2 pi, I have 2 pi thirds plus 2 pi, that's times 3, so that's just plus 6 pi thirds, which is 8 pi thirds, divided by 3 again is going to be 8 pi thirds. So I'm going to get cosine of 8 pi ninths plus I sine of 8. Questions about that? Yeah. Yes, because you're dividing by 3 every time. And again, the standard form part, if you got this part right, the standard form part's just typing it in your calculator. It's the trig part that you have to do some work on. So I'll type that in. 2 times cosine of 8 pi over 9. And that gave me negative 1.88. And 2 times sine of 8 pi over 9 gives me 0.68. So plus 0.68 pi. Then we got one more. And some people are going to be like, if you write it out once, You might not show all the work the next time because you can just know that that's going to now become a 2. So now you're going to be adding 4 pi. I usually show this one little step here to kind of help me with my work there. Scroll down here. So k equals 2. I'm going to say the cube root of 8 times the cosine of 2 pi, or sometimes I just write 4 pi, but I'm going to show you the formula. 2 pi times 2, still divided by 3. Again, all that's changing each time in your formula is the k value, but that changes your theta altogether when you put that together. So now that's 4 pi plus 2 pi thirds. So is that going to be 14 pi ninths? Just adding 2 pi thirds plus 4 pi. So that would be 2 pi thirds multiplied by 3 is just 12 pi thirds. So that's 14 pi thirds. Then divided by 3 is going to make the ninths 14 pi ninths. So I get 2 times the cosine of 14 pi plus I sine of 14 pi. Yes. But in standard form, I got 0.35 and negative 0.98, so minus 0.98 I. So look at those trig ones for a minute. Look at those angles. 2 pi ninths, 8 pi ninths, 14 pi ninths. You see a pattern? On that one, maybe I didn't multiply. Yep, I forgot to multiply by 2. Thank you. 1.975. You got the cosine one though? The 0.35 you got? 2 pi ninths, 8 pi ninths, 14 pi ninths. You see pattern? What do you think if there was a fourth one, which there's not, but it's cube roots? Do you have a guess of what the angle would be on the next one? How'd you get that? For the top, right? From 2 to 8, we added 6. If you add 6 to 8, you get 14. There's not a pattern that you can figure out before you start it, but there's going to always be a pattern because you're adding a multiple of 2 pi. So if there's one that I say find the 5th roots, there should be no need that you have to work that out 5 times, because after you do 2, or maybe you do the 3rd one just to make sure that you did the first 2 correctly, you should see that there's a pattern, and then you can just go from there, because there's always a pattern, because it's just this pattern of a formula of that you're multiplying by 2 pi. It's not always at 6. It changes with each one. We'll look at the next one, and we'll look at that one too. But I just want you to know that there is kind of a shortcut with that if you do a couple of them. So if you see one that says find the 5th roots, it's not nearly as bad as it could be to do that. Okay? So notice this one says find the cube roots of 1,000. It's just like if I said solve this equation, x cubed equals 1,000. What would you say if I said solve the equation before say, forget about all this trig stuff for a minute. If I said x cubed equals 1,000, what would you say? You'd say 10, because 10 cubed equals 1,000. But there are 2 other solutions. There's one real solution, and then there's 2 imaginary solutions. Because every fundamental theorem of algebra, every equation, polynomial equation, has n roots. And so if you realize that 10 is one of them, and you want to tell me 10, right, it's going to be one of those k equals 0, k equals 1, k equals 2. It's going to be one of those, and then the other 2 are going to be the imaginary. The other way you can solve this problem is you can factor, how about this? This would go back here. Remember factoring a difference of cubes? Like a cubed minus b cubed. And then the second one is a quadratic that gets you two imaginary answers. That's another way that you can get these three solutions. We did that first, like, beginning of the year. We did that. We did that in Algebra 2. So it's not something that you haven't done before, but this is just a way of finding all the nth roots of a number using trig. Okay, so just wanted to kind of throw that out there. So notice it's 1,000, which means what is my trig form of this, right? A plus bi. That's just a, right? So it's just like 1,000 plus 0i. Which means where's that graph? Like what would theta be if I just graphed 1,000 and then 0 for that? A is the real part. Which one's the real? X or Y? Right? So wouldn't that just be like out here at 1,000? So what would theta be? If it was just like an imaginary number, then your theta would be at I have. So it's if it was negative 1,000, we'd be over at pi. Right? Everybody with me where I got that? What's my R? Not 0. R is your distance from 0 to this point, right? It's just 1,000. If you do the thing, it'd be 1,000 squared plus 0 squared. Square root of that, which is just 1,000. Right? Sometimes the individual numbers kind of throw us off a bit. So this would be in trig form 1,000 times cosine of 0 plus I sine of 0. Cube root, which means I'm doing n is 3 again. So I'm going to do k equals 0. The cube root of 1,000 times the cosine of 0 plus 2 pi times 0 divided by what? Three, because n is 3. It's the cube roots. If it would have said the fourth roots, I would be divided by 4. The cube root of 1,000 is just 10. This is just a whole bunch of zeros here. 0 plus 0 is 0, and 0 divided by 3 is still 0. Which means in standard form, I think that just gives us our perfect root, right? And we can show it here. The cosine of 0 is 1. The sine of 0 is 0. So you just get 10 as your answer, which we knew was an answer. Because cosine of 0, right? That's your trig value. At 0, the ordered pair is 1, 0. Now we just got to do it 2 more times. So k equals 1. I don't know how we are on this. I'll just write it. Cube root of 1,000 times the cosine of 0 plus 2 pi times 1, all divided by 3. My original angle is still 0. K is changing to 1, dividing by 3. Some people like to do all the trig stuff first, and then go back to the standard form. Some people do each one together, whatever you want to do. So again, that's just 10. But now, 0, that's nice that it's 0, because now we just have 2 pi divided by 3. So that's the cosine of 2 pi thirds plus I sine of 2 pi thirds. Then yet again, we're back to unit circle stuff of having to know your value at 2 pi thirds. That's over here. So that, I believe, is negative 1/2. and sine is radical 3 over 2, which gives me negative 5 plus 5I radical 3, because I'm multiplying the 10 through there. Questions on where I got that? Right. You mean with on your calculator? So I don't want. Well, you could because you'd get 0.5, but I don't want a decimal. Right? The reason that it works on the reason you could give me a decimal, an ugly decimal on this one, is because 2 pi ninths is not from your unit circle, so you don't have a choice but to give me a decimal. But 2 pi thirds, I want an exact answer. If it's from the unit circle, I don't want decimals. But you could plug it in your calculator, and hopefully if you didn't know your unit circle values, it could help you. Because if you do cosine of 2 pi thirds, it's going to give you 0.5, and it's going to tell you that, and so hopefully that would help you know that the sine is radical 3 over 2. But that's why I want the exact answer. Then I'm going to do it again for k equals 2. So I'm going to have the cube root of 1,000 times cosine of 0 plus 2 pi times 2 divided by 3. Which is going to be 4 pi thirds. Again, it's really nice when it's the cosine, when the first angle is 0, because I'm just taking 2 pi times 2 divided by 3. And if you think about solutions with imaginary solutions, like Matthew was asking earlier about the square roots, usually, like, you don't have an imaginary solution without its conjugate, which means sometimes people are going to just, I think, maybe recognize what the other solution is going to be. And I'm going to show you where it comes from, and then it's up to you on how you do that. But 4 pi thirds is down here, which means they're both negative. So again, it's just like 2 pi thirds, same pair, but now we're down here where they're both negative. So it's still going to be negative 1/2. But now it's also going to be minus radical 3 over 2. And again, if you remember anything about conjugate pairs, an imaginary number never shows up by itself. Its conjugate is always with it. And so if negative 5 plus 5I radical 3 is a solution, it should make sense that negative 5 minus 5I radical 3 is also a solution to that problem. So the equation x cubed equals 1,000. This is one way that you could get the 3 solutions to that. I don't know if it's maybe the best way, but it's one way that you could get this. When you get bigger than cube roots, I think that this is, I mean, I don't know what other way I would solve something like to the 5th power and find all 5 solutions without doing this. That is okay. So this is your last homework assignment for the chapter besides review. 39 and 44 say find the cube roots. One of those is in trig form already, one of them isn't. Alright? And then 46, 46 is a big one, but it's already in trig form for you. And again, I want you to look for the pattern. And then 55 is a big one too. But look for the pattern. Once you do 3, you just look for the pattern and you should be able to get them. I'm sure we'll do like one of these tomorrow, but I'm not going to do, like, there's only 4 problems, and so if you get stuck on them, I'll be glad to answer your questions, but I'm not going to do both 46 and 55. Those are the 2 big ones. So, that's right. Definitely test this week, so if